Hello, welcome to Biosys 3. Today we'll talk about the properties of enzymes. This will be the last lecture before our next exam. And on this coming Thursday, you will have a quiz. You have an online quiz again. And next week, you will have the online exam. So we'll talk about factors affecting enzymes, some clinical application about metabolic diseases, and also very important, oxidation and reduction. Together we call it redox, the redox reaction. So let's see what are the factors that affect the enzymatic reaction. So the first one is the substrate concentration. So what is substrate concentration and how does it affect the reaction? So enzyme activity will increase as the substrate concentration increases. The reason is that there will be more collision between substrate and enzyme, meaning that the chances of a substrate binds to an enzyme will be higher. So this is what it means, the collision. And the maximum rate is achieved when all active sites bind to. Oh, okay. So if you have a limited number of enzymes, but the substrate is a lot more than enzyme, then in this case, all the active site of the enzyme are already bind with the substrate, then you achieve the maximum rate of the reaction. Because all enzymes, they are occupied, they are very busy, they don't have extra active site to bind more substrate. That means their hands are full, and then that's all they can do. So that's why we call it a maximum rate. So here is the what you may call it steps. So substrate concentration continue to increase. Then the enzyme substrate collision increase. That means their chances of meeting each other or the chances of substrate binding to the enzyme continue to increase. And then the enzyme activity will also increase. Until when? Until all enzymes are occupied by the substrate, then they reach the maximum rate. So in here, you can see that this yellow thingy here is the enzyme. This brown looks like chocolate. The yellow looks like cookies, and then the brown circle looks like chocolate. So the brown circle is the substrate. Normally as we increase the substrate concentration, we will increase the enzyme activity. So these two are directly proportional to each other. But if we keep on increasing the substrate concentration, then enzyme will become something called limiting factor or the bottleneck. After all enzymes they are occupied by the substrate, then we call it maximum rate. So this is what I just talked about in terms of graph. This is what the graph look like. You can see that when there's a low concentration of substrate, then when we increase the when this is the substrate concentration, when we increase the substrate concentration, then the rate of the reaction will also increase. But as we continue to increase substrate concentration, when all the enzyme that are occupied then it will reach something called a maximum rate. So this is the graphical representation of what we just talked about in the last two slides. So what are the effect of substrate concentration? Okay, it's a substrate increase because there are more collision. Okay, maximum rate achieved when all active. Well, we already talked about this. So the last picture explained to you why the maximum rate achieved when all the active sites they are filled continuously with the substrate. It is due to the continuous increase of the substrate concentration. So we just keep, it's like in a factory, okay, we only have a certain number of factory workers, but we keep giving them work, a lot of work, so that all the hands of the factory worker, they are occupied. So that will become their maximum production rate. So the factory worker is like the enzyme. The work that we give the factory worker is like the substrate. Okay, we will talk about the second factor, temperature, and the second factor, pH, together. So enzyme activity increases as temperature increases. So enzyme activity is directly proportional to the temperature. This is the first property. As a matter of fact, it's not just enzyme activity. It's basically almost all chemical reaction. When you increase temperature, then the chemical reaction will also increase the rate. It will become faster. That's the reason. Increasing temperature is basically you supply more energy to the system so that the system will have more energy to carry out the reaction. The more energy they have, the faster the reaction will proceed. So it explained to you that more effective collision is the same thing we talked about. It's the same thing we talked about in the previous slides. When we increase the temperature, then both the enzyme and substrate, they will gain energy. When they gain energy, guess what? They will move faster. It's like the kinetic energy we talked about previously. They will gain energy and then convert it into kinetic energies, then they move faster. When they move faster, then the chances of a substrate binding to the enzyme or the chances of they collide will increases. So that's what it means. When the chances of the substrate binding to the active site increases, then it will the reaction. Then you have more reaction. That's why the reaction rate will increase. But too high temperature is not good. Why? It can denature enzyme. What does it mean, denature? Denature, well, most of the enzymes, they're protein. So if you heat up a protein, let's say if you cook an egg, so, okay, the egg white, they are protein. So if you heat an egg, what will happen? The transparent liquid egg white will become opaque or opaque white solid. So the egg white will become opaque white solid. We call it denature. Denature meaning that the structure of the protein change. When the structure of the protein change, the active site on the enzyme will also change the shape. And in this case, the enzyme can no longer bind to its original substrate. Then, that's what it means. Inhibiting its ability to bind to a substrate. And because the active site changed the shape, the substrate can no longer bind to the active site, then the enzyme cannot catalyze or speed up the conversion of the substrate into product. So this is what we mean denature. The heat changes the structure of the enzyme. Just like when you cook eggs, it changes the egg white. Hypothermia or heat shock. Body protein denature starts at 40 degrees Celsius. compared to 37-degree normal body temperature. That's why high temperature fever is very dangerous and it can kill people. If you are 40 degrees Celsius, it's already too high. I mean, if it is 39, it is already very high. So you need to take Tylenol or Advil to lower your body temperature, to lower the fever. Well, I would say mild fever or low temperature fever is good in that it helps to fight infection. But too high fever, like 40 degrees Celsius, that's too much. It denatures the protein, it will kill you. So do not let your fever go too high. It's not good to your body. So the first picture is important because it tells you the temperature, the function of temperature. As you can see that the highest rate is very close to 40 degrees Celsius. It's very close. It is approximately 37 degrees. It is approximately 37 degrees Celsius. Because our body temperature, 37 degrees Celsius, is like the optimal temperature for our body enzyme to work. If there's any changes in the body temperature, let's say if it increases the body temperature, then you have fever, then it will decrease the rate of the reaction because the protein will denature. Or if you are hypothermia, meaning that if you're freezing, you will also decrease the body temperature. You will also decrease the rate. Hypothermia is this direction. You will also decrease the rate of the reaction. And then we'll give you some example. Okay, ectothermic animals like lizard or snake or most of reptile, they are ectothermic animal, meaning that their body temperature changes according to the external environment. If there's a sun, heating up, then they will absorb a lot of energy. Then they can move really quickly. Remember, if you know that there's some lizard living in the desert, wow, they can run really fast. But during winter, the external temperature is cold. What will happen? They cannot move. So what they usually do, they go to hibernation. They find a safe place to sleep, so that during the cold winter, when they cannot move, then other predator will not be able to eat them. But the endotherm, or we call it isotherm, endothermic or isothermic animal, we keep our body temperature constant. That's the advantage. We can move, we can hunt, or we can escape danger even at cold temperature. But what is the drawback? Can you think about a drawback? What is the drawback of being an isotherm or endothermic animal? Let me give you 5 seconds to think about it. 5, 4, 3, 2, 1. Okay, time's up. So the drawback of being an isothermic, or we call it endothermic animal, is that we have to eat all the time. Yes, we have to eat all the time, so that when we break down the food we eat, it can generate heat. It will give us heat energy to keep our body warm. But the advantage of ectothermic animal like lizard and snakes, they don't need to eat very often. Yeah, because their body temperature depends on the external environment. So in other words, they save a lot of money. If you have a pet of a lizard or snake, well, not many people keep a snake as a lizard. If you have a pet as a lizard, then you don't need to feed them very often.